All right, so this is improper and mixed numbers. I think that you guys are going to find this pretty simple, okay? And it should look familiar to you. Hopefully it will look familiar to you. But if not, we will learn together. All right, so the first thing that we want to look at is improper fractions. All right, so let's take a definition here. Now, when I say improper, what does that mean? What does that make you think of? Like your behavior was improper. Zoe?
Like filthy.
Filthy? Okay. Yeah.
Like a New Zealand accent saying like that was improper or something.
Okay. She hears it in a New Zealand accent. Maybe English, right? Maybe. Okay, Lawson. Wrong. Now if I say, what is the proper thing to say here? Right? You would say something like please or thank you or, right, manners. I think like manners, bad manners, like that's improper, but he's absolutely right. It's wrong. Improper means wrong. So when I look at an improper fraction, I will know it immediately because the value is greater than, value is, my bad, greater than, come on mouse, let's go, or equal to 1. So write that down and then we'll talk about what it means. So an improper fraction is a fraction whose value, remember that means what it's worth, its total, right, is greater than or equal to 1 whole. Now that's a problem because what is the point of a fraction? What does a fraction show us? Zoe?
Math.
Okay. Alison?
Parts of something.
Parts of something. The purpose of a fraction is to show us how many pieces of a whole there are, right? The top shows us how many pieces we have. The bottom number shows us how many we need to make 1 whole. So if a fraction has a value that's equal or bigger than 1, it's an improper fraction and it doesn't make sense. So let me give you an example of that. All right, so improper fraction might look like 10 over 8. All right, some of you I see are still writing, so catch up with us. And then we'll talk about what this looks like. All right, so an example, again, would be 10 over 8. What do we notice about this fraction? What's wrong with it? Anna Banana.
Like, if you had a pie with 8 pieces,
Mm-hmm.
you can say you ate 10 of 8 pieces, then that would be wrong.
It would be wrong. So she's saying if you had 8 pieces in a pie, but we're showing that we ate 10 slices, it doesn't make any sense, right? It's impossible. So let's talk about what this might look like. So I'm going to go ahead and, I'm going to say cake. So I'm going to start with a cake with 4 slices, and then let me break it into 8. So here's the cake, and this is what she's talking about. If I have 8 slices, but my fraction says to shade 10, right? Everybody with me? So I'm going to go ahead and I'm just going to use my highlighter. You can just scribble scrabble in there if you need to. All right, and I'm going to. So what I need to do is I still have 2 more slices of cake to shade. So I'm going to make another cake here with 8 slices, and I'm going to go ahead and shade in slices 9 and 10. let's go ahead and let's label our cakes in fraction form. So Isaac, take a look at this first cake. How would you name this as a fraction? Remember, we're going to do part over whole. So what number would be on top of my fraction for this cake? 8. Out of how many slices? 8. All right, so there's fraction number 1. Now I'm going to add that to my fraction that I show for my second cake, which is what, Mr. Turner?
It was,
Name a fraction for this cake here. 2 eighths. Great job. So I have shaded 2 out of 8 here. And that gives me, now we haven't talked about this yet, but just super fast, if you are adding fractions, they have to have the same denominator on the bottom. Fortunately, we do, so we will keep that denominator, and then all you have to do is add your numerators, which gives me 10 over 8. So again, if I see a fraction that is bigger on top than it is on bottom, it is improper. And this fraction has a value of 1, right? 1 whole or greater. So let's talk about what we would actually call this. I'm going to do a little divider here. Can I keep going, or do we need a second? All right, so let's keep going. So if you have an improper fraction, one thing that we can do is we can rename it as a mixed number. So let's write that one down, and we'll define it, and then talk about what it looks like. So if I'm saying a mixed number, my definition is the sum. And just write all these words down, and then we'll break them up. The sum of a whole number and a fraction. Oh, my ink is giving out there. All right, so we've got the sum of a whole number and, let me scoot this over, a fraction. When I say sum, that is my math vocab for what? What is a sum? It's the answer to what, Ashton? Addition. So I am right above this, and I'm just going to put like a little plus sign. So it's the answer to an addition problem. So a mixed number is the sum, or the answer, the total, right, of a whole number and a fraction. A whole number and a fraction. All right, finish writing that down, and let's talk about an example. All right, so let's keep going. So an example that I would give you is a mixed number would look like something like 1 and 2 eighths. Okay? 1 and 2 eighths. Let me zoom in here. Okay?
What does that say?
1 and 2 eighths. Do I need to make it bigger? 1 and 2 eighths. Let's do that. How's that? Better-ish?
Yes.
That's an 8 on the bottom. I didn't make my snowman right. Okay, so let's talk about what this looks like visually. Now, anytime you have any kind of fraction, you need to draw any kind of fraction, deal with it, understand it, you have to know the denominator, okay? And what the denominator is what it will stay no matter what kind of fraction it is. Even if it's improper, if it's a mixed number, what is the denominator for this number? I see Anna's hand up. Who else can tell me what the denominator is here? See some more hands. The denominator. Snyder Spider. Do you see the denominator? What denominator am I going to work with here? What number gives me 1 whole? I need to know what that is. Sassafras, do you see it? 1 and 2 eighths. What number am I going to be working with here? Anybody? Mr. Turner, do you see it? Hannah Snyder, what is the denominator for this problem? It's an 8. So now it says that I have 1 whole. So if I have a whole, it has 8 pieces. If it's 1 whole, how much of it am I going to shade? Isaac, what do you think? The whole thing, all of it. This is 1 whole cake. Then I have 2 8, so let me draw that as well. Come on, ink, don't fail me now. So if I have 2 8s, I will shade in 2 pieces. I'm going to go ahead and label this again. I've got 1 plus 2 8s. That equals 1 and 2 8s. So catch up with me there. Okay. What do we notice about this mixed number? Does it look familiar? Anything about it look familiar? Everybody take a look at your paper and look at what we just did and ask, and what I'm asking is, does anything about it look familiar?
Yes.
Take a look at it until you can find a connection, because who knows who I will call on. Still got a couple of people looking down. Who will I pick on today?
Not me.
Sassafras. What do we notice? What do you notice about what we just wrote? What we just drew? Does it look familiar? Is it what can you connect it to?
What we did with the sprinkle.
Okay. Anybody else? Have something else? Eden. We did it with the improper fraction. So what we're saying here, when you look at the visual for my mixed number and you look at the visual we made for the improper fraction, 1 and 2 8s is equal to 10 over 8. These two things are the same. So write that down, and then let's talk about, Sissy, what's up? Why are we talking to Lawson Dawson? Do you need help with something? Can I help? Y'all just having a powwow? Showing him your notes?
No.
Just showing him a note? Do I need to read it? It's like an extra piece of paper. So we can see a visual.
Showing him the colors.
Oh, good. We can see visually that these two fractions are equal to each other. Okay? So let's talk about how do we get from one to the other without having to draw them, so that we can see what they are mathematically without having to draw them. Yes, Zoe?
I'm using numbers.
You use numbers. Okay, so I'm going to go ahead and jump to my next page. You can if you don't have room, or maybe you've already done it. Go ahead and number it over here. So let's talk about how we go from an improper fraction to a mixed number, and then a mixed number to an improper fraction. Now, let me get this out of the way. Okay, so let's start with improper to mixed. Now, my example will be $12 divided by 5. All right, so I immediately recognize my improper fraction because it is too big on top. Okay. Okay, is everybody good here? Do we need a second?
A second.
All right. All right, so let's take a look at this. So the first thing I want you to go ahead and write over here is that you are going to use this fraction. You're going to go from bottom to top. Okay? So go ahead and write that down. All right, so that means that we are going to look at our improper fraction, and we're going to start at the bottom and we're going to go to the top. Now, one thing that you might not be aware of, but a fraction is actually a division problem. Your fraction bar is actually a division bar. Okay, so if you didn't know that, now you do. But this is another way to write a division problem. And you will see it in the future. Okay?
So 12 divided by 5, typically?
It is. So the way we remember what goes into what is, again, we start from the bottom and we go to the top. So I literally will write my problem in the order from bottom to top. I start with the 5. And then, again, my fraction bar is my division bar. So I write my box and then I use my top number. So over here on my steps, I'm just going to put like bottom, top. Okay? So the bottom number will divide into the top number. Okay, make sure you have that down and then we'll keep talking. So when we divide those 12 pieces into groups of 5, we just do it the good old-fashioned way. And we solve and we end up with 2, remainder 2. All right, is everybody caught up with me? I just divided 5 into 12, so don't make it hard. Okay? Just divide 5 into 12 and we end up with 2, remainder 2. I followed the good old steps. I divided, multiplied, subtract. There's nothing to bring down, right? So I have a remainder. But I need to create a mixed number out of this. So I end up with my whole number, and I'm going to take my remainder, and it becomes the numerator. So the remainder equals the numerator. All right, so my answer will be 2 as my whole number. Again, if I have a remainder, anything left over becomes the numerator of my fraction, right? My remainder becomes my numerator, and what is my denominator? Ashton, what is my denominator in this problem? What did I start with? A 5. So that is equal to 12 over 5 that we started with. And that's how you go from an improper fraction to a mixed number. You're going to divide the bottom into the top, and you'll make the remainder a fraction. All right, so let's do a couple of more examples. All right, let's do a few more together, and then I'll give you some to try on your own. What about 17 thirds? So take a look at 17 thirds.
Why'd you put number 1 instead of example?
Whoa!
Yes, please.
So again, when we take a look, hang on one second, I'm just suddenly feeling a little nauseous. Whew. Okay, so again, when I see an improper fraction, if I am asked to change it into a mixed number, I'm going to look at this fraction from the bottom to the top, and I will write it in that order. I will say 3 divides into 17. How many times can I fit 3 into 17? Thank you for raising your hand. Eden? Was your hand up? Okay. And a banana? 5 times. So I divide, then I multiply. 3 times 5 is 15, and I subtract, leaving me with 5 remainder 2. Right, Miles? When I write, you write, son. Let's go. All right. So I have divided my bottom into my top, and now I will write my mixed number as 5. And what am I going to do with that remainder? It becomes a what? It becomes a
Denominator.
Not quite. Jacob? It becomes the numerator, and the denominator stays the same. We get it from our original problem. Okay? So again, 5 2/3 is the same as 17 over 3. A mixed number is, I don't even think we have, yeah, we did. Sum of a whole number and a fraction. Yeah, we defined it. So if I am creating a mixed number, I have to have a whole number and I have to have a fraction. Make your fraction out of your remainder. Okay, everybody good there?
No.
Finish writing. I'm going to go ahead and put down a second one.
Can we do it already?
Let's do one more together and then we'll give you some on your own. I guess it doesn't matter. Let's do 14:6, and the instructions say create a mixed number. Let's go ahead, everybody go ahead and set up the problem. And many of you are going to get to a point where you look at these and you can just write the mixed number without doing the division bar, okay? So, well, then you just can't do it, I guess. Sorry. We'll go to your math funeral someday. And I'll say, I tried, y'all, I tried. But here she lies with her crappy attitude. All right. Crappy math attitude. All right, so again, I will take the bottom number and divide it into the top and just do some nice, simple, single-digit division. 6 will go into 14 twice. I multiply to get 12. Subtract. And I have 2 left over with an answer. 2 remainder 2. Do you understand how to do this division?
Yes.
Okay, then I'm just doing it and then I'm giving you a chance to write it down. I don't think don't stress out when all I'm doing is 6 into 14, okay? All right, so make sure you have that down. Y'all, you don't even have to write this. If you just put this part right here, you have enough. Y'all know how to do this division, okay? Don't let it stress you out. And my last step will be to write my mixed number. So I said it went in twice. My remainder was 2, which I will use as my numerator, over my denominator, which is 6. Okay, so here's my 2. And here's where I get my 6. And that is my answer. Give me a thumbs up if you are with me. In the middle if you are getting there, and a thumbs down if you are still having a lot of trouble. Okay. Titus, where you at? Okay. I want you guys to try one by yourself. Just do me a favor. At least set up the problem. Okay? At least get to right here. Set this up. If you do nothing else, you should be able to do that. Okay? So let me give you one to do, and let's see how far you get. Let's do 24/9. Okay. I'm just going to draw the arrow to remind you. Okay, and if you are watching this, go ahead and I'm going to pause. You pause and take care of your problem, and then hit play to check the answer. All right, so talk to me. Raise your hand if you can tell me what's my first step and what does it look like in this problem. I want you to raise your hand right now if you can tell me the first step. Please, everyone, be able to tell me the first step. Put your hand up, high and proud. Let's go. The first step. Titus, do you know what the first step is? How do I set this up to get ready to solve it? What's my first step? Do you know? Divide what, sissy? What's my problem? What am I dividing?
Divide
9 into 24. Thank you. All right. What did we get? Raise your hand if you can tell me the answer. Lawson. 2?
Oh, the answer?
The answer is 2?
The final answer?
Yes. I want to know the answer to the division problem I have right in front of me. 9 goes into 24 2 times. 9 times 2 is 18, so that doesn't work. That can't be your final answer for the division problem. Somebody tell me what we get. How many times does 9 go into 24? Hannah Snyder Spider.
3.
3 times? 3 even? And that's it? 9 times 3 is 27? I don't think so. 9 goes into 24 2 times. 9 times 2 is 18. I subtract, and I have a remainder of 6. So my answer is 2, remainder 6. This is what I'm looking for right now. So what is my next step? Raise your hand if you can tell me. Jacob. Okay, so he says turn it into a mixed number. So 2 remainder 6 looks like what as a mixed number? 2 and 6 over 9. This is our final answer. I need you to give me a thumbs up or down. Please do not look around. Who got it? Who did not get it? Who got it? Who did not get it? Come on, let's go.
I did it.
All right, put your hands down. Who is brave enough to tell me what they got and why? Ashton.
I got 3 remainder 7, but I set up my problem right because I did 9 times 3 equals 18.
So you just multiplied wrong then?
Yeah.
Okay. All right. So we did a little multiplying wrong. Okay, that makes sense. Who else is brave enough to tell me why they got this wrong? Zoe.
I got
Huh?
yeah. I got this fractions. Yeah, I got 6, 9.
You got a 6?
Wait, hold on. No, 9, 6. Whatever.
Oh, you put 9, 6 on the fraction part? So you just mix them up
And then I got
Okay.
1 whole.
in one whole. Okay. So it looks.
I don't have a brain.
Stop it. All right. Anybody else want to tell me what they got and why? Yeah.
I didn't get a final answer.
You just didn't finish?
I
Okay.
did the division, and I got the division wrong because I wasn't thinking about it.
You just messed it up. Okay. Yeah, hey, listen. Sometimes when we get into these math problems and it's like that simple, sometimes we trick ourselves into thinking it can't be this easy and we make it harder than it is. Okay, so don't let that happen to you. Yeah, Allison.
I got it right.
Okay, congratulations. I didn't ask that. But thanks.
You said what?
Anybody want to say, Allison, you're a little extra. Woo, Allison. Okay. All right, let's try another one. Poor girl. Poor girl. Okay, here we go. And we're done. We've moved on. It's too late. Okay, let's try another one. Let's do, I'm just making this up as I go, 34 over 12. 34 over 12. All right, go ahead and make sure you can set it up correctly. Watch your division and keep it simple. And then put that into a mixed number. Okay, move on. Raise your hand and tell me, what is our first step? What do I do first, sassafras?
You divide 12 into 34.
12 into 34. What is the answer, Snyder Spider? How many times does 12 go into 34?
2.
What's your final answer on this?
2, 10, 12. That's what I got.
Okay, she said 2, remainder 10.
Yeah, that's what I got.
Okay,
I got that.
good. Now listen. Good job, y'all. Now, I need someone to turn this into a mixed number. Titus, can you do that? What is 2 remainder 10? How does that become a mixed number?
It's like
Uh-huh.
10, 12.
2 and 10 over 12 is perfect. All right, now show me. How are we doing? How did we do? Thumbs up if really quickly. Do not look around. Thumbs up if you got it. Thumbs down if you did not.
It makes a lot of sense.
Okay, it's better. It's better, right? All right. Let's do one more. Just one more, and then we can
Do backwards?
no, because we still need to do improper to mixed. So, I mean mixed numbers to improper numbers. All right, so let's do 47 thirds. Okay? Set up your next step and then take that answer and make it into a mixed number. All right, so let's check this one. Raise your hand if you want to tell us the division problem first. Jordan, what you got, honey? 3 divided into 47. Okay. Raise your hand if you want to tell me the full answer you got for this division problem. Allison with an E.
15 remainder 2.
15 remainder 2. Everybody agree?
Yes.
No.
And now I need the mixed number. Ashton, what did you get for the mixed number? Didn't finish it. Were they though? Oh, okay. All right. Raise your hand if you can tell me. I'm still recording and teaching right now. All right. So who can tell me the mixed number for this answer? Titus, you got it?
Yes.
Okay. What is it?
Is it
15 and 2/3 is absolutely correct. All right. Great job. Okay, guys. So it is lunchtime. I'm going to go ahead and okay, so ask it again. So we went through division to take an improper fraction and to make it into a mixed number. So the mixed number would be the opposite of that, right, Sissy? You're facing forward, knees forward, feet forward. So to go from the mixed number to an improper fraction, we have to undo and do the opposite of that. So what is that going to look like? And a banana. Okay, so what are we going to do then to go from the mixed number to the improper fraction? If we have to undo or do the opposite of the division, then what are we going to do with the mixed number? Snyder Spider.
Multiply.
We're going to do some multiplying. So let me start us here. And from here we're going to do mixed number to an improper. Gotcha, thank you. Let's do that. So we'll do mixed number to improper fraction. Okay. So let me come up with my example. Okay, and then we'll talk steps. All right, go ahead and get that written down. Pause if you need to. All right, so you guys said multiply. Okay, so I am going to start with my mixed number. Okay, and what I want you to do is I want you to think of drawing a C from the bottom up. Okay, so I'm going to have a C, and I'm going to draw it from the bottom and then up. Okay? So what I will do is I'm going to start down below, and I'm going to go in this direction inside my mixed number. Okay. So go ahead and make sure that you have your C here. And let's just draw some arrows so that we can tell what direction we are going in. Okay? We're going to start from the bottom, and we're going to draw that C backwards. Okay? That's really what I want you to think of. Like, don't even worry about these. Okay? I want you to think of... Wait, am I thinking backwards? Like drawing a C from the bottom? Like what am I? So if I'm starting here and I'm going up, like what makes sense? So like a C, like let's say from the bottom. I know. I'm trying to think. Well, you don't need to be confused. I mean, you can see the arrows. I'm just trying how to best to describe it. So, but I will start down here. Normally, I would write my C. Look, if I'm error writing, I would do this, right? But what I want to do is I want to start down here and draw it clockwise. Is everybody with me? So whatever you need to write there, I'm going to say C from the bottom, but I'm drawing it in this direction, in the direction that my arrows are moving. All right. All right, so guys, step 2. Step 2 is we are going to multiply the denominator and the whole number. All right, so go ahead and write that down. So I'm shortening this. I've got multiply, denominator, and whole number. I'm sorry. And I'm just going to put my X right here between these two numbers. So I'm going to start down below, and I'm going to say the denominator times the whole number. You guys just stay for 1 minute. I want you to finish these notes. Okay, denominator times the whole number. Is everybody with me? Okay, so that will be here, will be 4 times 4. So I'm just going to write it here next to the 2. Now, step 3, I will add the numerator. So I'm going to say add numerator here. Oops, am I running out of ink again? And I'm going to put a plus up here between the 4 and the 3. So now I have 4 times 4 plus 3. Move that up a little bit. Okay, take a second, pause the computer if you need to, but right, let's get that caught up. All right, so what you will do, again, you'll start down here in the bottom, and remember you're thinking like you're drawing a C from the bottom up, and you're going to go in that order. So I will say 4 times 4 is 16, right? Everybody look up here. Look up here. So I'm going to take the denominator times the whole number. 4 times 4 is 16, plus 3 is 19. Right? Now it's an improper fraction, so let me put that on top. What is my denominator? Look at, it's a 4. Yes, it's the 4. It comes straight from here. Okay, so again, I start from the bottom and I just go backwards. I go around in a, hey, they're finishing some notes. Can I send them to you in 1 minute?
Yes.
Okay, so I'm going to take 4 times 4 and I will add 3. And that gives me my numerator. And then I will add my denominator. Okay? Make sure you have that written down and let's do some more to practice. Sounds like from all that talking that we are ready. No, absolutely not. You have work to do in there. Okay, so let's do some practice of those. All right. Let's do 6 and 7/8. All right, let's start with that. 6 and 7/8. Now, again, what I'm going to do is I'm going to start from the bottom and I'm going to move around to the top, starting with the 8 and the 6. So I'm going to take that denominator and whole number, and I'm going to multiply those. I'm going to say 8 times 6, and then I will add the 7. Okay, so I'm going to write out what that looks like. So it will be 8 times 6 plus 7. Now, this is what I want to know from you after you write that down. Where are we at on this? Do you understand where all 3 of these numbers came from? Thumbs up if you're with me. In the middle if you think you know, and down if you do not understand. Where did I get the 8, the 6, and the 7? Okay. Thank you. So, let me also just add to this. I'm going to start here, down here, and I'm going to draw my arrow this way. Okay, so one of the things, that Sharpie is total trash. So, let me grab another one. So again, I will start here, and I am going to go in this direction. Are you with me? Start here at the 8, and I am going to use my numbers in this direction. So if you ever have any doubt, start at the bottom and move your way around. After that, all you have to remember is multiply and add. Multiply and add. When I start this first step, the 8 times 6, what I am doing is I'm taking the number 8 is how many I need to make a whole. So imagine if I was going to draw this mixed number. I would draw 6 cakes completely filled in. Are you with me? So what I can do, instead of saying 8 plus 8 plus 8 plus 8 plus 8 plus 8 6 times, is I can just multiply 8 times 6. Thumbs up if that makes sense. So what I want to do is represent all the pieces that those 6 cakes represent. There are 6 cakes and each of them have 8 slices. So 6 times 8 tells me how many pieces I have in 1, 2, 3, 4, 5, 6 cakes. Okay? When I add the numerator, that 7, remember that's like your remainder. So I have 6 cakes and then 7 pieces left out of the 7th cake. So I am multiplying 8 times 6 to show I have 48 slices inside those 6 cakes, plus another 7 slices in the last cake. Okay? So once I do that, I then put it over 8 because that's how many I need to make a whole, and that's my improper fraction. So 8 times 6 is 48. Then I add the 7 more slices, which gives me what, 55? Mm-hmm. 55 over what? My numerator stays, my denominator stays the same. And it's what? 6. No, 8.
8, yeah. 8.
All right. So this, you can't see that very well. So our improper fraction will be 55 over 8, and it is equal to 6 and 7/8. They are the same. Finish writing that, and let's do another. Can I keep going, or do we need another 30 seconds?
Another 40.
Don't be crazy.
I'm not.
40 seconds. I'll give you 21.
What about 5 minutes? What about 2 hours?
What about kindergarten?
Oh, that.
If it takes you that long to copy this, sayonara. Okay, let me pause this so they're not listening to all this. Okay, so... All right, let's do another one. Let's do 4 and 5/8. All right, so let's do this again together. I'm going to start down here at the 8, and again, I'm just going to go in this circle, this little C type, and I'm going to take my first 2 numbers, the 8 and the 4, and I will be multiplying those. So I'll start with 8 times 4. And then, for my third number, I will add 5. Now, again, hear me as you write. The first 2 numbers that I am multiplying represent how many pieces my whole numbers hold. Are y'all with me?
Yes, ma'am.
If I have 4 cakes, everybody understands that, right? Right, Hannah? You two girls, do not tell me you don't understand later when y'all over there chatting like old friends. And I'm going to tell you to go take a hike because you weren't listening. Now, I will take 4 cakes. They have 8 pieces each. 4 times 8 tells me I have 32 pieces. Okay? Plus, I have my fraction. So I have another 5 pieces. So 8 times 4 is 32 plus 5 equals 37 pieces, which is my numerator. Part over whole. Now, I'm going to put that over 8 right here. My denominator does not change. Okay? Yeah, just set it down. So that will remain the number I need to make a whole no matter what. Capiche? And it's that simple. You take those 3 numbers, you multiply the first 2, add the last one in, and make it a fraction. And I want us to do a few more. Give me a thumbs up if you would like to try one on your own. Okay? Go ahead and try it. So let's say that's number 1. I think I already numbered the other ones, but that's okay. Let's do 7 and 4/5. Okay, so go ahead and start this one on your own, and let's see how far everyone gets. Okay, so somebody tell me what's the first step that you took in solving this and making it an improper fraction? Ashton, what's the first thing we do?
Why are your fingers purple?
Hush.
Me?
Nope, y'all are off topic. Ashton, what's the first thing we do to solve this?
7 times. 7 times
Look at the problem above it. There's a multiplication sign. Where does the multiplication sign go? Right here, it was between the 8 and the 4.
Oh, okay. So 4 times 5, or 7 times 5.
You're right. 5 times 7, right? And then what do we do?
And then plus 4.
And plus 4. So 7 times 5 plus 4. Give me a thumbs up if you had that. If you got that far. Okay. Awesome. And Eden, what did you get for that number? 39 over 5. Anybody else have something different? That sounds good to me. All right, so we end up with 39 over 5. How do we feel? We got this? One more. Y'all prove it to me one more time. All right, 6 2/10. All right, I'm going to hit pause, and I want you guys to solve that, and we'll check it. No mewing. Loser. Okay. All right. And, hey, parents, these are your children. Miss Lewis's homeroom, just talking away. In case you're wondering. Y'all just keep talking it up for your parents here. Solving this for us.
Me, please.
Ashton?
Yay. 6 times.
She did solve the last one.
I'm good at it.
Move on. All right, go.
6 times 10 plus 2.
6 times 10 plus 2. Somebody tell me what that gives us. I can't call on you. Somebody will get mad. Eden. I can't hear you. 62 what, Jordan? What's my fraction?
62 over 10.
Thank you, sir. All right, so let's do this. Let's take a look. Go ahead and get out your math workbook. Whoa, that's my line, sir. That is my line, Titus. You do not lend to anybody, Mr. Turner. No. I know you've wanted to say it for a while, but no. All right. Okay, darlings, here we go.
We're coming.
Turn on over to page 107 for me.
Come on, darling.
All right. I can't hear it myself, so I'm pretty sure you can't hear me either. So let's go ahead and put your name in there.
What page did you say?
107. So what? Tomorrow's the 19th, 20, 21, 22. All right. Listen, darlings. Put your name in there. And go ahead and write on there, do Monday, 422. Okay, do Monday, 422. Now, listen to me very carefully, and I'm saying this, it will be on YouTube and Google Classroom. So I want you to hear this, Isaac. You ready? I'm going to walk through every section of this, and I'm going to give you some instructions and make sure you understand it. If you choose to work ahead and you come to me later and say, I don't understand what these directions mean, I'm going to tell you to take a hike. Because you chose to work ahead while I walked through this paper section by section. I will not repeat it for you. Okay? Do you understand what I'm saying to you?
Yes, ma'am.
If you make that choice knowing you choose your own consequence. Now number 1, 2, and 3, 1 through 6 says circle or draw lines to group the figures. Write the equivalent fraction in lower terms. So what they want you to do, guys, is first we're going to write this as an improper fraction. Okay? Now, if they're asking you to circle or draw lines to group the figures, honestly, I would say just mark that first line out and just write what you have here. The only thing really that might help you is when you're doing this mixed number, I could circle 1 hole, 2 holes, right? That might help you some, but you should be able to recognize that I've got 1, 2 full sections, right? Which I will mark here under mixed numbers. Then I need to name my fraction for this third section, which is what, Snyder Spider? What is this last one? 1/3. Now, when I go to mark this as an improper fraction, I will count every single shaded box. 1, 2, 3, 4, 5, 6, and 7. 7 will go on top. Now, what goes on the bottom? What goes on the bottom? Because I will tell you, the other class got this wrong. What do you think, Jacob? 3. It's 3. If you're not sure, look at the holes and count how many pieces make 1 hole, okay? There was some confusion about that in the other class, so make sure you're paying attention to each of these. How many are in each one? That's your denominator. That's your denominator. Now, over here on 5 and 6, on number 5, right here, this little diamond, this is what you're naming. You will use this bottom section, you will use the 2, right, to say what the mixed number is, and then you will focus more on these top numbers for the improper fraction. I'm not going to help you with it right now. I want you to look at it and see what you can do with it. For number 6, again, we have not talked about adding fractions, but just as a reminder, if I'm going to add any fractions, they have to have the same denominator. So in each section, I will have a 5 as my denominator. Now, in order to count for the numerator, I'm going to have to add the numerators. Okay? So the only thing that will change is you will add up the numerators. I would start with the improper fraction and then do the mixed number. Okay? All right. So, now, for this next section, it says picture the improper fraction. Okay? I am not really worried about you drawing this. Okay? If you want to, you can. It might help you. But what I am interested in is you writing the mixed number or whole number. So if you have an improper fraction, guys, you're going to change it into a mixed number. And they all look like mixed numbers. Yeah, so you'll change all of those to a mixed number. Any questions about that? Yeah, Jordan.
I still don't understand 5 and 6. Yeah.
Same.
Yes, I don't understand.
All right. I will do 5 with you, but this is what we're going to do for 6. I want you to look at it, and there are some things, he's not even here, there are some things that you can figure out if you look at them long enough, okay? And if you guys still just cannot get it, and no one in here can explain it, then I will talk about it, okay? So, but I do agree that the number line is a little weird. So let's talk about number 6 first as a mixed number. Down below of this number line are my what? I see 0, 1, 2, 3. What kind of numbers are those? Eden? They are not denominators. That's a good guess, though. Think about if I pulled out my ruler here, and I'm going to start measuring, and you can see here I've got a 1, a 2, a 3. Like, are these fractions? These 1, 2, 3? What kind of numbers are they?
Inches?
They're inches. In a mixed number, what would they be? The whole numbers, yes. So down here below are my whole numbers. So you can see that my diamond is between the 2 and the 3. So what is my whole number? Focus, focus. What is my whole number?
3.
Nope, I'm in between 2 and 3.
8.
Oh my. I see y'all's hands. I just want to get some more up. So I make it. I've gone all the way. I've got at least one hole. Now I'm here on in my chart. I've got 2 holes. I don't have 3 because I didn't make it that far. How far did I make it? To what, Jacob? To the 2. Yes. So I've got a 2 for my whole number. Now what I need to do is figure out what my fraction is between the 2 and the 3. So up here, I can see based on the 6/3 and the 9/3, what am I counting by in between? To get from 2 to 3, let's take a look at it. And I want you to count how many hops we move over. To get to 2, I've got 1, 2, then I land in 3. What's my denominator? It's 3, yeah. That's how many steps I need to take until I get to my next whole number. In between 2 and 3, I have 3 steps. How many did I land on? Right there with that blue dot. I went 1, 2. Are you guys with me? All right, I'm hearing a lot of silence, so I want to make sure. So that becomes 2 and 2/3. So again, I'm going to pull right up to this, and I want you guys to look at it really carefully. It says, get your stuff. It says you're going home for the day. Get your stuff and go home for the day. All right, so you guys look up here. Again, here I am on the 2. So if I have not made it all the way to the 3, the lines and the steps in between tell me how many make a whole. That is my denominator. So here I am on 2. Now watch, I go to the first line, that's 1. To the next line is 2. And then I land on the 3. That's 3 steps to get from 2 to 3. That means I have to make 3 steps in order to make one hole. Give me a thumbs up if you are with me. In the middle or down. Go. Thumbs. Okay. Some of you are there. Now I want to look at this one more time. Okay. Does everyone see that I have a 2 and a 3 here? Are you with me?
No.
Those are my whole numbers. To get from a 2 or a 3, I have to do these steps in between. Does that make sense? Give me a thumbs up if you are with me. There are lines in between the 2 and the 3. I have to pass all of those to get from 2 to 3. Give me a thumbs up if you are with me. I swear on the Holy Bible, y'all better start. Where are we at? Thumbs up, middle, down. Come on. Come on. All right, we're getting there. Do you understand that? You know what? Okay, hang on a second. Hang on one second. Let me look at this. I'm going to do this right here, nice and clean. I had a 1, I had a 2, and I had a 3. You do not have to write this. I want you to look at it. Now, if you are looking at a number line, what? Did you say something, Lawson? Good. Okay, good. So, if I am looking at these numbers on a number line, just like I said we could do with what do I do with my ruler? Just like we could do possibly like with a ruler here, right? 1 inch, 2 inch, 3 inches. And then we have all of these in between, right? 1/4 inch, 1/2 inch, 3/4, etc. Now, what they gave you in between was this. And right here is where they put your line. Okay? So if I am looking at this like a fraction, I have to say that going from 1 to 2 is one whole. And what that looks like, if I was just going to draw it, would be this. Okay? Now let me show you why. To get from 1 to 2, this is one whole, right? Now here are my pieces of my cake that I identified 1, 2, 3. I've got one piece here. Here's my second piece. And when I get to the 2, there's my third piece. Give me a thumbs up if you're with me so far. Waiting on Titus. Eden, waiting on you. Just set it down. Okay. Are you with me? Okay. So, again, I have 1, 2, 3 sections for between 1 and 2. This is one whole. So if I look between 2 and 3, it's the same thing. I definitely have gone to the 2. So there's my whole number for the 2. Now what I need to do is count how many pieces I've gotten to here. So here I've gone from 2 to the first line. That's 1. Now I go to the second line, and that is 2. So if I have 3 pieces, I didn't go, if I got the third piece, I would have my whole cake, right? I went to 1, 2 pieces. So I'm going to think of those as shaded in. Now, to represent that as a fraction, to represent this as a fraction, I'm going to say that I'm at 2 out of the 3 steps. What you'll have to do, guys, if you have any kind of number line, number 1, figure out where are the whole numbers. 1 to 2, 2 to 3. After that, step 2 will be counting how many steps, and you need to think of them like bunny hops like you did back in first grade, okay? You need to count them as 1, because you don't start here and say 1, 2, because then you get here. You need to go 1, 2, 3. Those are the pieces right here, and right here. These are your 1, 2, 3 slices of cake, okay? You have to count how many spaces you have between the 1 and the 2, or the 2 and the 3. That gives you your denominator. Give me a thumbs up if you're with me in the middle. If you're getting there, thumbs down if you are still completely confused. Okay, all right. So that one is done for you, however. So we won't have to worry about that again. The only other thing I'm going to say for number 6 is that I would focus on the fact that you are adding, and I would look at the numerators. Okay? Hold on to this. Keep it in your book, and let's finish going over it tomorrow, and then we will assign it. Okay? Okay. All right. So it is time to go. Go ahead and pack up. Jordan wants you to go run and take a break.